Hi everyone, so welcome back to chapter 5 states of matter. We will look into detail for 5.1 gases and ideal gas equation. Let's look at ideal gas law. Ideal gas law is a combination of Boyle's law, where volume is inversely proportional to pressure, Charles' law, volume is directly proportional to temperature, and Avogadro's law, where volume is directly proportional to number of mole. So if you combine all of them, you will get this relationship. Okay, so ideal gas law equation describe how volume of a gas is affected by pressure, temperature, and number of mole. So if you rearrange them, you will come to PV is directly proportional when you have N and T, number of mole and temperature. And if you want to write an equation for this, okay, so if you want to put an equal sign here, means you need to substitute here with constant. So in this case, we will use gas constant. R is for gas constant, and the value for gas constant is, we will use the second one here, which is 0.08206 liter atm per Kelvin per mole. So ini yang akan kita pakai throughout chapter 5, and for chemistry kita akan banyak guna this one lah for this chapter. So how can we get this? Bila kamu rearrange the equation, R equals to PV over NT. So pressure dalam ATM and volume in liter over mole, and temperature must be in Kelvin. So there you go. Macam mana dapat liter ATM per Kelvin per mole. Okay. And if the question give you value untuk pressure dalam torr, means you need to convert into ATM before you substitute into the equation of ideal gas equation. Okay, same goes to the others, such as volume must be in liter, and then temperature must be in Kelvin. For ideal gas law, you can use it to determine pressure, temperature, relative molecular mass, and density just by rearranging this equation. Okay, for example, if you want to find pressure from the PV equals to nRT, you just rearrange nRT over volume. And if you want to find temperature, just rearrange them into PV over nR. There you got your temperature of the gas. What if you want to find molecular mass and density? So let's have a look. For relative molecular mass, okay, you know that mole N is equal to mass over molar mass. So from the equation PV equals to nRT, you have mole, number of mole here. Okay, so number of mole is mass over molar mass. So when you substitute, okay, you will get PV equals to mass times RT. R is the gas constant times temperature, and then divided by molar mass. So if you want to find molar mass of the gas or molecular mass of the gas, just rearrange this, okay, to another side, and then kamu akan dapat M mass times gas constant times temperature over pressure times volume. Okay, so just substitute dalam equation. Next, if you want to find density, you know that density is mass over volume, m over v. So from the equation, PV equals to nRT. Okay, convertkan satu-satu. And okay, we know from previous slide, mole is mass over molar mass. Okay, so here. And then if you want to find density, volume, you rearrange to this side. Okay, so there you go. Di sini, this side, mass over volume. Okay, so if you want to find density or if the question give you information about density, you can use this formula lah. Dekat sini boleh substitute sebagai density. Or if you want to find density, just rearrange this formula and then density is equals to pressure times molar mass over gas constant times temperature. And from the equation PV equals to nRT, you can also find concentration. So concentration, you know that the formula is mole over volume. So if you substitute, kamu akan dapat concentration equals to pressure over gas constant times temperature. And make sure unit dia mesti pressure must be in atm for all the ideal gas equation, and temperature must be in Kelvin, and volume must be in liter or dm cube. Okay, so for the value of gas constant that we will use, so remember R adalah gas constant. Okay, inside the equation of PV equals to nRT. So we will normally use value of R sini is this one. Okay, 0.08206 atm liter per mole per Kelvin, and unit for pressure is atm, volume is liter ataupun dm cube. So kalau kamu tak ingat the value of this gas constant, you can refer to the list of constant provided dalam exam. Okay, make sure you need to make sure unit kamu betul, unit sama, same on both sides, then only you can proceed with the calculation. This will help you with unit conversion. So let's say you are given with this unit, millimeter mercury. So just refer to the list and then convert pergi ATM and so on lah untuk all the value yang ada dalam soalan. Okay, so let's look at the example 1. So this question, okay, I've already provided with the answer solution. So let's have a look. Calculate the volume in liter occupied by 2.12 mole of nitric acid. So this is the mole N. And then 6.54 atm is the pressure. And then 76 degrees Celsius is the temperature. So from here, you can extract the information and you can double check whether it satisfy untuk masuk substitute lah dalam this equation. So pressure already in atm, and then you want to find volume, mole dah ada, gas constant, and then temperature, since ini dalam degree Celsius, so convert pergi Kelvin. So you will get 349 Kelvin. So masukkan dalam formula PV equals to nRT, and then you will get the answer 9.0 Okay, and then you will get your answer 9.28 liter. Okay. For next question, what is the mass of Cl2 chlorine gas that contained in 1.4 liter vessel? So ini adalah volume, and 740 millimeter mercury, this is the pressure, and then 45 degrees Celsius is the temperature. Okay, so you can see ini dah liter, ngam. And then for pressure, must convert to atm first. And then for temperature, you must convert to Kelvin. Okay, barulah you can substitute into the equation. Equation of PV equals to nRT here. Okay, so for this question, okay, when you substitute, you will get n number of mole, which is this one, and then you need to find mass of Cl2 gas. So mole is equals to mass over molar mass. Okay, so just substitute lah, masuk. Kamu akan dapat mass is 3.7 as this one. Okay, gram. Don't forget to write the final answer punya unit. And for next example, okay, a vacuum tube is closed at pressure of, okay, so this is the pressure in torr and at room temperature, so this is the temperature and must be converted to Kelvin. And volume given is 100 cm cube. And what is the number of gas molecule that is trapped in this tube? Okay, so by using PV equals to nRT, kamu akan dapat number of mole, and then make sure when you calculate number of mole, di sini mesti ada unit, walaupun this is not your final answer yet. Bukan yang paling akhir, but then this is the final answer for this first calculation. Okay. So next, when you want to find number of gases molecule, so satu molecule you have Avogadro ini kan, 6.02 exponent 23. If you have this much of mole, so berapa molecule that exists, okay, yang ada. So you have 5.83 exponent 13 molecule. Example 5, calculate the density of ammonia in gram per liter at 0.989 atm at 47 degree. So you have the molar mass or molecular mass of ammonia, 17 gram per mole. And then to find density, just use the formula. And you have pressure in atm or D, dia punya molecular mass, and gas constant, and your temperature, convert to Kelvin, and then you will get your final answer 0.64 gram per liter. Next, for example 6, calculate the density of carbon dioxide in gram per liter. So ini sama juga, dia nak minta density, okay, in gram per liter. So you just use formula and make sure you substitute them. Okay, ni in atm or D. So temperature you must convert pergi Kelvin, and then you will get your answer. This is your final answer, 1.23 gram per liter.